Now that we understand what reverse engineering is and why it's essential, let's shift our focus to the actual process. Like any specialized activity, reverse engineering follows a series of structured steps. These steps help us systematically extract information about software, making our analysis reliable, reusable, and helpful for developers. Now let's break this down piece by piece, starting with one of the most overlooked but important parts. In reverse engineering, we had first the seeking approval phase. Reverse engineering isn't something you just jump into, especially with proprietary software. Ethically and often legally, you need permission from the software's owner before conducting any form of analysis. Now, that's not just about politeness, it's about legal protection. If you find a vulnerability, the best practice is to report it privately to the software vendor. That's what they say. And that gives them time to fix it before it's disclosed to public. Now, reducing the risk of the flaw being exploited. And that said, there's a very different set of rules when it comes to a malware. And if you are analyzing a malicious executable, you don't need to others' permission, obviously. In fact, you are trying to expose that the author and understand their creation to stop further harm. However, if there's ever uncertainty, especially in a corporate environment, consulting legal counsel is always a wise step. And then we have the static analysis phase. Now, this is where we begin our analysis without ever running the program. Now, think of it like dissecting a frog without bringing it to life, opening up the binary file, scanning each byte, and reading its intervals. Now, from the file structure and the metadata to embedded strings and headers, a lot can be discovered in this phase here. Like, is it a exe, DLL, dynamic link library, or ELF format, and so on and so forth. Or we also can know what architecture is built on, like x86 for computers, ARM, or 64-bit. And are there readable strings or API calls? So you are essentially preparing your mind and toolset for what you might encounter once the program runs. And then we have the dynamic analysis phase. Now let the software run, but carefully. This is where we place the program inside a virtual cage, typically a virtual machine, and watch what it does. Does it create files, change the registry, connect to suspicious domains, install persistence mechanisms? Now, this form of analysis mimics a zoo. So we want to see the malware's behavior in its natural habitat, but without letting it escape. So we use logging tools, file monitors, network sniffers, and behavior analysis frameworks to catch every move the software makes. And then we have the low-level analysis. Sometimes static and dynamic analysis just aren't enough here. Malwares may use tricks like environment detection, so it can detect that it runs in a virtual machine and just delete itself and just doesn't work as intended in its natural habitat. That's very clever of malware developers. They can use tricks like environment detection or time bombs, or only activating under certain conditions. There's more instances about the last one here. Now there's where low-level analysis comes in, using a debugger like x64dbg or gdb and debug dbg. We step through the program's execution line by line, instruction by instruction, and this is where you will see exactly what code executes conditionally, what branches the logic follows, and how values are passed and manipulated in memory, and also how system calls, APIs, application programming interfaces, are trained. Now, this meticulously work, but it is crucial for understanding stealthy and conditional behavior. And one of the last phase is reporting. Reporting. Now, sometimes you won't have to report things, but this is a official phase for reverse engineering. Now, here, by reporting, I mean you are reporting your findings. Now, documentation is as important as the analysis itself in professional environments. And a good report doesn't just summarize findings, it tells a story. Now, think of your analysis as a crime scene investigation and your report as a case file. You may ask the questions: what does the software do? What do specific behaviors trigger? Why were certain instructions or libraries used? Where is the software intended to run? And how does it interact with its environment? Now, these reports help future analysts, developers, and security teams learn from previous discoveries. Now, for example, documenting a buffer overflow found during analysis could lead to future input validation improvements across multiple applications. And the tools of the trade to make all this possible, we use a wide array of specialized tools, which you will learn by detailed in next lectures. And these tools have each specific role. In the binary analysis tools, these help us inspect file formats, headers, and extract strings. Example include PAID, detect is easy, and binvalk. We will use these tools in next lectures. Now, we also use the disassemblers, tools like IDE Pro, Ghidra, which is free and open source, developed by NSA. Now, Ghidra lets us see the raw assembly instructions within an executable. We will also use the decompilers. These provide higher level views of code, translating low level machine instructions into something resembling the C or Java. Ghidra also does that, or we also have the JEP, for example, GADX, and we will also use the debuggers. Debuggers allows us to pause and step through execution. We use them to trace behavior and identify hidden logic. For the debuggers, we will mainly use GDB. And we will also use monitoring tools like Procmon, Wireshark. Actually, I have a full 10-hour course on Wireshark. You can check it out. And we will also use the Process Explorer monitor system. We can also monitor the system level activity during execution. And these tools continue to evolve alongside modern software, and no single tool here is enough. It is your judgment, creativity, and understanding of the reverse engineering process that ultimately unlock the software's secrets. And this layered approach, approval, static analysis, dynamic analysis, low-level analysis, reporting, forms the core of professional reverse engineering practice. As we continue this course, we will explore each of these phases with real-world samples, tools in action, and hands-on workflows to sharpen your skills. Thank you for watching. My name is Stefan, and I'm waiting you in the next lecture.